Hello fellow problem solvers. So they're going to be doing a geometry problem, which I suggest you try out for a minimum of 10 minutes, ideally 20 to 30, not more than an hour. If you'd like to go along with us, draw the diagram. Put your first ideas out on paper for the next 10 minutes. And now without further ado, let's begin. So let's draw the diagram first. We have the smallest side is BC. Okay, boom, bada boom. This is alpha. This is not our isosceles triangle, as you see, it's tilted a bit on this side, BCA, and I have these two angles are alpha, so it's this one's alpha, and also this one right here is alpha. We have the points, these are called P and Q, right? PC, actually no, it's like P and Q, the opposite. It doesn't matter in this problem. And we have their circumcircle is O of APQ. We must prove that BO is CO. Now, there are two ways to go about solving this problem. One is forwards or backwards. Forwards is seeing what is it that we have from this being alpha and this being alpha. Backwards is saying, hey, what do I actually need to prove? All right, so let's go at it. You can choose which way you want to go at it. I invite you to pause for 5 minutes and pick. We're going to go forwards now. Go forwards with us for 5 minutes, okay? Go now. I hope you did. And what do you see? So for me, this is alpha, this is alpha. This here whole is gamma minus alpha, gamma minus alpha. I have this as beta, and this is gamma. But I have a similarity between CQB and CBA. And this similarity gives me a lot of things, but I like to look at it as the power of points with respect to C, that the CB is actually a tangent to this circumcircle. So CB squared is CQ times CA. Similarly, I have also, this is BC squared is equal to BP times BA. I don't even need to look at anything else because I know P and Q are symmetrically defined. If I have this for C, I have pretty much the same thing for B. And that's going at the problem forwards. And there's also these similarities, which we can write down. This angle is 2 alpha. What else? So now I can go at it backwards. And I say I can't need OB's OC. How do I connect B and O? Like, that's the big question. How do I connect these two? And the answer is actually you use power of point. Meaning, if BO is CO, what does that mean? Well, that means that the power of point B with respect to this circle is going to be B O squared minus, if the radius is say R, minus R squared of this circle. Radius of this circle is R. And then this is going to equal CO squared minus R squared, which really is true if and only if B and C have the same power of point, like the power of B with respect to call this circle gamma, and is the same of the power of point of C with respect to this circle. Now, what is the power of point for B with respect to this circle? I mean, on one hand, it's this, but on the other hand, it's BP times BA. And this power is equal to CQ times CA. But when going at the problem forwards, we've already figured out that these two things are actually equal to BC squared. So in fact, we have these two things are both, they're both equal to BC squared. And so their powers of points are equal, and so these two things are equal, which means that BO is CO. And this is just an application of power of point, this problem. And it goes to show where you use it. Where you actually not where you use it, but where you can see as a hint, maybe I should try to see if I can get a power of point right. BO, CO, it's like, please. That's a power of point. And as always, thanks for problem solving.